Close your eyes for a moment. Think about the word ocean. What comes next? Maybe it's waves. Maybe it's blue or deep or salt. Maybe it's a memory, a beach from childhood, the smell of sunscreen, the sound of your mother calling you back from the water's edge. Whatever arose in your mind just now, it didn't come from nowhere. It came from pattern, from every time you've encountered that word before, every context it lived in, every association you've built across a lifetime of language and experience. You just did, in the space of a breath, what a large language model does billions of times per second. You predicted. The story of LLMs doesn't begin with computers. It begins with curiosity about ourselves. In the 1940s, scientists started asking a dangerous question. What if we could build something that thinks? Not a calculator that crunches numbers, but something that learns. Something that recognizes patterns the way we do. They looked at the brain, that 3-pound universe of neurons firing and connecting, and wondered if they could capture its essence in mathematics. A neuron, after all, is simple in principle. It receives signals, and if enough signals arrive with enough strength, it fires and sends its own signal onward. A yes or no switch, influenced by its neighbors. What makes the brain extraordinary isn't the individual neuron, it's the connections. 100 billion neurons, each connected to thousands of others, creating a web of such staggering complexity that it gives rise to consciousness itself. The artificial neuron was born from this understanding, a mathematical function that takes inputs, weights them, and produces an output. Simple, almost disappointingly simple. But then you connect them, layer upon layer, input flowing through hidden depths to output, and something emerges that none of the individual pieces could achieve alone. Think about how a child learns language. No one sits a 2-year-old down with a grammar textbook. No one explains the subjunctive mood or the proper use of the semicolon. Instead, the child listens, absorbs, picks up patterns without ever being told the rules. Want cookie becomes I want a cookie, not through correction, but through exposure, through hearing the pattern 1,000 times until it becomes instinct. A large language model learns the same way. It reads everything we've ever written, or at least vast swaths of it. Books and articles, conversations and code, poetry and product manuals. It doesn't understand the way you understand. It doesn't know what a cookie tastes like, or why a child might want one. But it learns the patterns. It learns that after I want to comes something you can hold or experience. It learns that questions end with question marks, and that, however, often introduces a counterpoint. It learns the rhythm of language, the dance of words that follow other words, and then it predicts. One word at a time, it asks, given everything that came before, what word is most likely to come next? Here's where scale changes everything. Imagine a mixing board in a recording studio, those long consoles covered in sliders and knobs. Each knob adjusts something, the bass, the treble, the reverb, the balance between instruments. A large language model has knobs too. We call them parameters, but not dozens, not thousands, billions. Each parameter is a tiny adjustment to how the model weighs connections and predicts patterns. During training, these billions of knobs are slowly, painstakingly adjusted. When the model predicts the wrong word, the knobs turn slightly. Millions of examples, billions of adjustments, until the model becomes remarkably good at the only thing it's trying to do, predict the next word. The large and large language model isn't marketing. It's the essential ingredient. It's what allows patterns of such subtlety and nuance to emerge that the output feels, sometimes eerily, like thought. This is where we must be careful. An LLM is not a brain. It doesn't have experiences. It doesn't remember your conversation after the session ends, unless specifically designed to. It doesn't want anything, fear anything, hope for anything. It's a mirror that reflects patterns. When you look into it and see something that feels like understanding, you're seeing a reflection of humanity's collective output, the patterns of millions of people who came before, captured in mathematics. This isn't a criticism, it's just precision. A mirror can still be useful. A mirror can still show you things you couldn't see alone, but it helps to know what you're looking at. Here's what moves me about this technology, when I set aside the hype and the fear. When you talk to an LLM, you're talking to an echo of us. Every book it trained on was written by someone who sat down, alone with their thoughts, and tried to put something into words. Every article, every story, every rambling forum post, they all came from human minds trying to communicate. The model carries a little piece of everyone who ever put words to a page. It's not conscious, it's not alive. But it is, in its strange, mathematical way, a monument to human expression, a testament to how much we've said, how much we've tried to understand and be understood. When you type a question and receive an answer, you're participating in a conversation that spans centuries of human thought, compressed and reflected back through silicon and statistics. That's not magic, but it might be something like magic's quieter cousin, wonder. The future's already here, and you get to decide who you are in it. Please subscribe, please like.
Just be.